Real zeros of a polynomial function. First thing we have here is the division algorithm that states that given a polynomial dividend fx and a non-zero polynomial divisor d, where the degree of dx is less than or equal to the degree of fx, there exists a unique polynomial qx and rx such that fx, which was the dividend, equals d, which is the divisor. There exists unique qx and rx, which this is what we call the quotient, and that's what we see below here. Q is the quotient and rx is the remainder. The remainder is either equal to 0 or has degree strictly less than dx, the divisor. If rx is 0, then dx divides evenly into fx. This means that in this case, both dx and qx are factors of f. So let's take a look at a long division problem dealing with polynomials. Now here go some problems below. We're not going to use synthetic division here. We're actually going to find the quotient, but we're going to use long division. And I want to use long division so you can really see how this division algorithm works and really see what these components mean. And I think that's important when we start to get into some of the stuff later on. All right, so let's take a look at this. I'll keep that there. Okay, so anyways, I'm just going to take this first one. So this right here, this 3x cubed minus 2x squared plus x minus 4, that's going to be my dividend. And this dx here, polynomial divisor, that's this number here, that's my polynomial divisor. All right, so let's get started now. Oops, trying to cross it off real good. Okay, so anyways, so now I have the x minus 3 outside. And then on the inside, I'm going to have 3x cubed minus 2x squared plus x minus 4. And we're just going to do a long division here. Now, before we actually get started, I just want to point out one thing. Remember, when I have these components here, I want to make sure I'm in descending order by the powers. So again, I have an x cubed, an x squared, an x, and a number. Now, if I was missing, let's say this x squared wasn't there. Let's say I took it away. And say let's say this is all I had here. I would have to put a 0x squared in there so that I had it in descending powers completely. So just kind of keep that in mind as you go through these two. Okay, so now let's do our long division. So what I'm going to do is, that's 2 terms, and this is 2 terms. So my first thing I'm going to do is, what am I going to multiply x by to get 3x cubed? And hopefully everyone's okay with 3x squared. Because I'm going to multiply here, and what's 3x squared times x? That's going to be 3x cubed. And that's all I need to get is this first number. And whatever I get for the second is whatever I get for the second. Now I'm going to do the same thing and multiply it by the second now. Because remember, taking this monomial and timesing it by a binomial, so it's a distributive process here. And that's why we're doing both of them. So this is going to be a plus, minus 9x squared. So now we're going to take this, what we got, and subtract it from it. So now I get 3x squared minus a 3x squared. That's going to be 0. And then now I have this negative 2x squared minus a negative 9. So that means that's really a plus 9x squared. So that's going to be a 7x squared positive. Because this is really together a plus 9x squared. And I have a negative 2x squared there. So together, that's going to give me a positive 7x squared. And then I bring down the next thing. So that's going to be plus x. So now I go through the process again. What do I got to multiply x by to get 7x squared? And we would say plus 7x. And now remember, I should write it in such a way that I'm over each term that I'm actually dropping down there. So I can keep my order with all this. So that's going to be 7x squared. And then I have negative 21x for the next one. Now I'm taking that and subtracting it. So that's going to be 22x. Because I'm minusing a negative 21, which is really adding a 21. And I have a plus 1 here, so I'm really adding them, 22x. And these go away, cancel out. So then I bring down the next thing, which is a minus 4. And then I go through the same thing. So I'm going to take this x here and multiply it by 22. So that's going to be 22x. And then that's going to be minus 66. So now I'm going to take that and subtract it. And that means I'm really adding 66. And I got a negative 4 up top here, right here. So then that means I'm going to get a 62. And that's going to be my remainder, 62. One way we can write this is we can write plus 62 over the number we're dividing with to write this out completely. But I'm going to leave that alone for now. And another way we did it is we wrote R62, remainder of 62. Now let's take a look at all of these components again. So first off, we had the polynomial dividend, and that was this number under here. Okay. Then we also had the divisor, and that was this number here. That expression there, that's my divisor. And then we also had this QX, and that QX they called the quotient. And that's what we see down here, the quotient. And the answer we came up with here, that's the quotient, the QX. And then one more thing to see here is we have the remainder, which is Rx. And that's what we see here, the 62, is that Rx. Now, anytime I have an Rx doesn't necessarily mean it has to have an X in it. It could just be a number, and this one happens to be just the number 62. One thing we also see here is that our Rx was not 0. It's not equal to 0. So that tells us then that this x minus 3 does not divide the dividend, which was at 3x cubed minus 2x squared plus x minus 4. So therefore, it didn't divide it, and there's our setup. So if I wanted to write it exactly like this here, I would get my fx that's, oh, that's huge. So there's my red one there. And that's going to equal my d. So that was x minus 3. And then my qx, that was 3x squared plus 7x plus 22. And then we had our remainder plus 62. So that would be the setup if we wrote it out as the division algorithm here. So this would be my fx. There's my equals, my dx is that there, my qx is this piece here, and then plus my rx. So there's our setup for all of it there.